Hi folks, we're going to look at a couple of more questions from our Unit 5 assessment. So now I'm at Unit 5 Quiz 2, and we'll take a look at number 1. So a very common question is to give you the graph of a function and for you to come up with the algebraic representation, in other words, the equation. Okay, so here we're looking for the equation, the domain, range, and the asymptotes. Okay, first thing I would do as soon as you see a reciprocal function would be to indicate the asymptotes on the graph. So here, pretty clear that these lines are the lines of the asymptotes. So let's write them down since they're actually asking us for them. Okay, I would do this even if they weren't asking for the asymptote, so we'll see why in a second. So here we see that we have a horizontal asymptote of y equals -2. Okay, and we have a vertical asymptote which crosses at x equals 3, so x equals 3 is the equation of the asymptote. Okay, now once you have the asymptotes, you can easily write down the domain and range. Okay, because those asymptotes represent the only x and y values that will not be in the domain and range. So for the domain, okay, x can be any real number, and the only one it cannot be is 3. Okay, so we can say x not equal to 3. And then for the range, similarly, y can be any real number, but the only number it will not take on will be where the asymptote lies. So y not equal to -2. Okay, now let's go to find the equation. So keep in mind that we saw that we can completely avoid using the b value or the horizontal stretch when coming up with an equation for these functions. Okay, so that leaves us one less variable to come up with. So given that this is a reciprocal function, okay, I want to use a general form that incorporates the reciprocal function. So I've got my a value, my vertical stretch, okay, then my function is 1 over x, but of course I might have a horizontal translation, so I'll have my 1 over x minus h, and then plus k represents my vertical translation. Okay, and now it's about looking at the asymptotes to figure out what my translations will be. So normally for 1 over x, my asymptotes are the x and y axes. So I see that the vertical asymptote was shifted over to the right by 3 units. So in the equation, I know that I will have x minus 3, which represents a horizontal shift 3 units to the right. Okay, and I see that the horizontal asymptote, which is normally the x-axis, has been shifted down by 2 units. So my k will just be -2. Okay, so now we see that we have only one of our unknowns left, the a value, and the way we find that is by inputting a point on the curve. So here you look around and you try to find a nice point on the curve, and let's see, there's a nice point on the curve, there's another nice point on the curve. I'll use this one here. Numbers are a little smaller and they're positive. Okay, so now I can input the point 2, 1 into the equation. So y equals 1, okay, 1 over x equals 2, so 2 minus 3, and now the only unknown left is a. Okay, so I can solve for a. So bring the 2 to the other side. 1 plus 2 is 3. Okay, this is 1 over -1, so that's just -1, so -a. And so a divided both sides by -1 is -3. Okay, and so now I've got my final answer, y equals -3, 1 over x minus 3 minus 2. Okay, let's just see if this makes sense. Okay, the stretch is tough to see on a reciprocal function, but definitely I can see that it should have a reflection in the x-axis, because normally this branch here will be on top. That one here would be on the bottom, so it makes sense that there's been a reflection in the x-axis. And then as we talked about, we see that the asymptotes have moved 3 to the right, 2 down, so that means these two parts also make sense. Okay, that's it for now.